Kia ora, Year 12. Here are two excellence questions from last year's differentiation paper. Now, I think it's a little surprising that this first one is an excellence question, and when you look at the schedule, it gets you a T1 mark. So it's kind of like a baby excellence question. The most you can get for the whole of question 3 from this one is an E7, but that's still pretty good. The second question is about a lamp being suspended over the centre of a round table, and I think there's at least one person from last year's A-level class who won't want to watch this video because I remember talking about it with him after class. So the second excellence question, you really have to have a think before you start. Okay, so let's do the first one. For what values of x is this function increasing? The first thing we need to do is to say what it means for a function to be increasing. Okay, so a few words. So increasing means f dash of x is positive. So what we've got is we've got y is equal to x over x squared plus 4. That gives us dy by dx. I feel like we've had a lot of quotient rule in this exam paper, but here's another one. So square the bottom line, copy it up to the numerator, differentiate the top, and then go the other way around. So it should be that fast for you guys as well, and we need that to be strictly positive. So that tells me that I've got in the numerator x squared minus 2x squared, so negative x squared plus 4 divided by x squared plus 4 squared is positive. So that's the same as 4 minus x squared is greater than 0 because the denominator is always positive. So solving 4 minus x squared is greater than 0, we've got 2 minus x, 2 plus x is greater than 0. The other way we can do that I think I'd like most of you doing, is first of all to rearrange it as negative x squared plus 4 is positive, x squared minus 4 is negative. So I want you doing it that way because it's really easy to screw up inequality sign changes, so just be careful with that. And so x squared minus 4 is less than 0 is a very easy quadratic inequality, which is why I'm kind of surprised that they gave it a T code, but hey, there you go. So I'm just looking at your graph. Where is it negative? Well, it's negative between -2 and x. So f of x is increasing here in that range. All right, let's look at the more fun and trickier question, which is the 3e. So this is definitely an E8 question. And I think if you just need to work slowly through the wording and have a think about what's variable and what's constant. Right, so we've got a lamp suspended above the centre of a round table of radius r. And the height is adjustable, right? So what we're looking at is the lamp can go up or the lamp can go down. And we've got point P on the edge of the table. We're given a formula from somewhere, physics, I guess, for illumination. So illumination is directly proportional to the cosine of angle theta in the above diagram, and it's inversely proportional to the square of the distance to the lamp. Okay, but you can see that as you pull up that lamp, what's going to happen? Well, the thing that's not going to happen is that r is not going to change, right? So that's the key to this question, I think, is to know that r is just a constant. Otherwise, it feels like you've got so much going on. So we've got h here, we've got theta in here, and we've got s in here. And then we've got this thing here, which is a problem, right? We've got I, and it's got cos of theta, and it's got s squared in it. Both of those things are going to change. So we have to somehow get this in terms of one variable, and that's not too bad at all. So if we look at theta, we've got cosine of theta in that numerator. What's cosine of theta? Well, cosine of theta is simply h over s. So once we see that, then we can replace all of this. We've got I is equal to k times h over s squared. So I is equal to kh over s squared. But now we've still got two variables because we've got h and s. So what's the other thing I can use from this question? I need to be able to eliminate either the h or the s. And in here, you can see that if you forget about that theta, you've also got a Pythagoras relationship, and that's what's going to help us here. We've got s squared is equal to h squared plus r squared. So I'm sitting with this formula down here, which is, oh, mistake there. So I is equal to kh over s cubed. We can replace the we can replace the s using Pythagoras. The reason I want to do that is because I want to show that maximum illumination is when h is equal to the radius over root 2. So that means I'd like to have an r in this expression somewhere. So we're going to use s squared is equal to h squared plus r squared, and that means that s cubed is equal to this to the power of 3 over 2. Okay, so we're just about there. Now all we've got to do is a little bit of differentiation work. So we've got kh over h squared plus r squared to the power of 3 over 2. For maximum I, we need to have di by dh equals 0. So there's a lot of work in this question to get to the starting point. So what's di by dh? Well, it's the quotient rule again. We've got h squared plus r squared to the power of 3 over 2 all squared. Plonk that up the top. And now differentiate the numerator with respect to h times k minus kh times 3 over 2 times h squared plus r squared to the 1/2 times the derivative of the inside function, which is 2h. And that has to equal 0. What you've got to remember right through there is that the radius of the table doesn't change, right? A table is a table. It's got a fixed radius. It's the height and the slant height of the lamp and the angle that can change. Now this looks horrendous, but it really isn't, right? Because we don't need to worry about this. So just cleaning up what we've got here, I'll do one cleanup line first, and then we'll factorize some stuff out. So here we've got minus 2kh squared, 2 times 3 over 2. So 2 times 3 over 2 gives me minus 3kh squared times h squared plus r squared to the 1/2. You can see that we've got some common factors. We've got a common factor of k. We've got a common factor of h squared plus r squared to the power of 1/2. That leaves me with h squared plus r squared to the power of 1, right, to make up the 3 over 2, minus 3h squared is equal to 0. So how nice is this question, right? So either k times that is equal to 0, which it won't be, right? Not valid. So it doesn't give me maximum. So that would give me s equals 0. So it's not that it's not valid. It's just that it would give me minimum illumination. Right, just going back to all the way back to that picture, that would be saying if we pushed this down to here, we're going to get an s. Are we? How are we going to get an s of 0? Let's have a think. Forget about that. Let's see. Well, we can't get this being 0 because actually we definitely can't have it being 0. Guys, I'm not going to redo this. This is just my brain thinking out loud here. So no solutions because the radius of the table is not 0, right? The root of r squared is greater than 0. So there's no solutions to that side. That means the only solution for maximum illumination is going to be r squared minus 2h squared equals 0. This is such a nice question. Look, we've got r squared equals 2h squared. And now h squared is equal to r squared over 2. So h is equal to the square root of that. And it's positive, so that's why I'm only taking the square root, not the plus or minus square root. And h is equal to r on root 2 as required. So there you go. That's one of four excellence questions in this paper. I'll do the other two after I've had some food.